everybody! In this video, I'm going to show you all how to decide which equation to use out of the three that we have learned so far related to molarity, mass percent, and dilution calculations. I am referring to your half sheet that you all have received on Friday, April 13th. For number 1, it says calculate the mass of KCl required to prepare 250 milliliters of 0.250 molar solution. Now, just by looking at the information provided, you'll know you have to use the molarity equation, not the dilution equation. The reason behind this is because in the problem, they only give you one value for the volume and one value for the molarity. Notice for the dilution calculation, you would need either 2 molarity values or 2 volume values. Okay, so because we know we will be using this equation, we could just go ahead and plug in our molarity into here. So if we plug our molarity into there, we get 0.250 molarity. Or notice molarity is also equal to moles over liters. And this molarity is equal to your moles of solute, which we do not know, so we will call X, and divided by the liters of solution. They give us 250 milliliters, but don't forget the bottom always has to be in liters, so we are going to convert the 250 to liters, which will be 0.250 liters. So I went ahead and rewrote it on a separate sheet of paper. So again, this is your setup to solve for how many moles of your solute. You're going to cross multiply. So you'll get 1 times X is equal to X. You have 0.25 moles over liters times 0.250 liters. So notice, don't forget, moles over liters is the same as capital M, right? But now you can know this is how your liters cancel. So when you multiply 0.250 times 0.250, you'll get 0.0625 moles of your solute, which is KCl. But you are not done just yet. The question asks you for the mass of KCl. Just remember, you can convert your moles to mass by using the molar mass of KCl. So we know that for every 1 mole of KCl, it is going to weigh 74.6 grams of KCl. So notice the reason why we put the 1 mole at the bottom is because we want the moles to cancel. And then all you have to do is multiply the top, and that will give you 4.66 grams of KCl. When you multiply 0.0625 times 74.6 grams. Now for number 2, it says how many grams of NaBr is needed to make 50 grams of a 5% NaBr solution. So just by looking at the information, they give us 50 grams of a 5% NaBr solution. So this 50 grams represents the grams of the solution. And they also give us the mass percent of NaBr. So just by looking at those two information, we know you're going to use this equation, because this equation is the only one that gives you the grams of solution and also mass percent. So I'm going to rewrite the equation here. So we have mass percent equals your grams of solute over your grams of solution times 100. We know your grams of solution is 50, so I'm going to plug 50 grams of solution at the bottom. They also give you the mass percent of your solute, which is 5, so we'll plug it in here. They do not give us our grams of solute, so we'll just call that your X grams of solute. And then don't forget you have to multiply by 100. So to solve for X, what we're going to do is we can divide both sides by 100 to get rid of the 100. So the reason why we divide is right now we are multiplying by 100. So if we divide by 100, okay, we can cancel out this 100 right here. So I'm going to rewrite the full equation again. So now we have 5 divided by 100 equals X grams of solute over your 50 grams of solution. So because you're dividing by 100, that's why you can get rid of this percent. And to solve for X, you could just simply cross multiply. So what you'll get is 100 times X is 100X. That is equal to 5 times 50, which is 250 grams. Okay, and then to solve for X, you're going to divide both sides by 100. So your X is equal to 2.50 grams of your solute, which is NaBr. And that's it for this problem, because this problem is only asking you for the mass of the solute. For number 3, it says a 0.500 molar solution is to be diluted to 500 milliliters of a 0.150 molar solution. How many milliliters of the 0.500 molar solution are required? So, based off of this question, you know you're given 2 molarity values and 1 volume. Based off of that information, you know you will have to use this equation here because it has a place for 2 molarity values and also a volume. So I'm going to go ahead and rewrite the equation M1V1 equals to M2V2. Your M1 is going to be 0.500 because whenever you make a dilution, you always start out with the greater concentration solution. So pretend that the solution is Kool-Aid. You always start out with a sweeter Kool-Aid, and then when you dilute it by adding water, it becomes less dilute, which is why the second molarity is less than 0.500. Okay? The problem says 500 milliliters of 0.150, so the V2 is 500 milliliters. So what you're solving for is your V1. So before we begin, we'll notice that the molarities cancel out. If you multiply the right side first, you will get 75 milliliters, and on the left side is still 0.500 times V1. To solve for your initial volume, you'll divide both sides by 0.500, 0.500. So these cancel out, so your V1 is equal to 150 milliliters. And lastly, for number 4, it says you have 53.4 milliliters of a 1.50 molar solution of NaCl on hand. What concentration in molarity of solution will you make if you ended up making 100 milliliters of solution? So in this problem, they give you 1 and 2 values for volume, and they give you 1 molarity value. So looking back at our equations, you'll know you would have to use this third one, a dilution, because they give you 2 volume values that you could plug in here, and they give you 1 molarity, so you have to solve for the other. Okay, so again, I'll rewrite the equation. M1 V1 equals M2 V2. According to the problem, it says 53.4 milliliters of a 1.50 molar solution is on hand. So meaning that is what you have right now. So 1.50 molarity is going to be your M1, and so your V1 is going to be 53.4 milliliters. It asks for what concentration in molarity. So M2 is what you will be solving for, because M stands for molarity. Of solution will you make if you ended up making 100 milliliters of the solution? So your V2 is going to be 100 milliliters. Notice your milliliters will cancel out. So your answer should be in units of molarity, which makes sense because you're solving for M2. If we solve the left side first, you will get 1.50 times 53.4 is equal to 80.1 molarity. This is equal to M2 times 100. To solve for M2, you're going to divide both sides by 100. So divided by 100, so 100 cancels out. So you're left with 80.1 divided by 100, which is 0.801 molar solution. And this will be your answer. So now that we walked through all 4 problems together, you can go back, and if you want to test or quiz yourself, you can retry those 4 problems. But other than that, I hope you have a good rest of your day, and I will see you back in class. Bye!